So I'm running a test run of the force calibration part with 3DM ABS. I went over to Kudo3D's office today and lunch with Jonathan, and we were talking about kind of the 3DM VATs and the 170-hour life of the VATs in the V2 VAT. You want to watch this? And it occurred to me that I haven't yet tried printing with it. So I, later in the evening after I got back from work, decided I was going to try this out here. And I'm trying right now the default settings, a 70-second attachment layer, and then from layers 2 through 15 at a 100 micron Z. I've got, I had a 45-second exposure time, which is what I paused to show you. That seems like a bit much. The stick to that was pretty intense. That 45-second support stick is way more intense than what I got from the FunToDo industrial blend, where for the support region from layers 2 to 15, or initial support regions, I typically use about 15 seconds there. And it seems like maybe I should go down to around that, because 45 seconds generated way too much stick. Now I'm doing layers 16 through 45, which is basically the upper support layers and the lower part of the flat. And that is going at 10-second exposure. And this seems more typical. Jonathan mentioned that they noticed that FunToDo was more sticky than 3DM, and which made me interested in trying this, since I have a bunch of this. And they also had a 3DM ABS part in the office, and what struck me, and what I want to compare, is how hard that piece is. The 3DM ABS piece was very, very hard. And part of it may have been because it was small and solid, but I haven't gotten any parts from the different resins I've tried so far that hard, so I wanted to see what this would look like on one of my own parts, particularly in comparison to the Venus Creator Clear, since this resin is orange and pretty translucent. I kind of like this orange translucent color. But it's obviously not totally clear, and this color should be good for blocking blue and UV to reduce the amount of overcure. So we'll see how this turns out. I'm only using 4 sections right now. The upper attachment layer down to the first ½ millimeter of the part are at 10 seconds, and then I'm dropping from 4.5 millimeters up to 10 millimeters, dropping the exposure down to 8.25, which is, there was another guy whose name I forget who printed the that spherical piece using 3DM ABS, and these are based on his settings, which were already lower than the stock Kudo3D settings. And this is something that I have to think about and maybe try, is since I'm printing really big parts, really dosing the layers with light in each section is pretty much guaranteed failure. The stick to the bed, kind of like the difference between that first separation I showed you when I first started talking and what's going on right now. When I give it a really heavy dose, it sticks pretty strong to the bed. And so there's always a sweet spot that I look for between sticking to the bed and reducing layer separation artifacts, like I don't know if you can see this. Oh yeah, you can. Good. Like these separation marks here at the bottom of this piece, which were kind of ripped apart cause that layer to be a little bit ripped apart during separation. This end is the end closest to the stationary end, so there's no matching artifact on the back side of this part. And there's a dance, right? You don't want it to stick too much. But then what I find is, since it's not, fully cured, not all of the shrink is out of the part. And so after I cure it, and really even after I cure it, and then 3 days later, the part continues to shrink, and develops a bit of a bow, which I might show you after I come back from the break. And so there's also a question of like, well, if I dose each layer really hard, does that reduce the amount of shrinkage that will happen later, and perhaps reduce the overall shrink in the part? And that's an interesting question. I don't know. I'll have to experiment more. But right now, I kind of have a deadline coming up. My tech shop buddy is coming up to visit at the end of the week, and so I was hoping to be ready to try out some injection molding this weekend. But I only have half the mold done. There's only this half that's been filled with epoxy, and so I got to get this other half printed successfully in the next 2 days, so that we can go try and do a test injection shot. And that, of course, will be a very exciting video. Anyway, so I'll let this run for a bit. Layer 36. Well, actually, I want to show you. I'm on layer 37 now. I should hit the first fully solid layer when I hit layer 41. So I might wait until I hit layer 41 before I take a break, so you don't have to sit here for another 15 minutes watching boring layers go up and down. But alright, layer 38 is going down now. So hopefully another minute or so, and we should see, there we go, it's going down. So this is the first fully solid layer going down at a 10-second exposure. Let's see what the release looks like. Oh, failure. Oh, that was bad. Okay. Not enough lift. Oh, that was bad. Okay. I should have guessed. Let's see if that detached it from the bed or not. Okay, after a little bit of that help on that first bit piece, 3mm seems to be enough. This is also one of those tricky things, right? This layer and the previous 3 layers, same exposure, same surface area. The first one that went down after the transition, right? You notice it didn't have a complete separation, and I had to help it by holding this guy down. Oh, I had another one. But then sometimes it's okay. That last one was not. Anyway, so I've got to babysit this part a bit to get it out. I won't make you sit through this. We'll come back when the part is done. Quick stop in the middle. I'm down in the 8.2 second exposure range. It seems to be releasing itself now. Fairly okay. So I guess dropping the exposure from 10 to 8.2 reduced the amount of stick. Not that I had any way of changing the exposure while I was printing. It just happens that from layer 46 and up, I dropped the exposure. So So now that 3 second is working okay. Actually, no, something is wrong. It's lifting, but I can see something down at the bottom. It's like I have a failed piece of the vat at the bottom, but the remainder is still curing. That's a little weird. Don't know what's gonna happen. Clearly, something is building. And that cured layer is going to reduce the exposure times. Strange. Anyway, we'll see what happened at the end. Could be something interesting. Alright, I guess whatever was left at the bottom of the vat was just a false alarm. Because there's nothing there, although a bubble has formed due to the... That's an interesting thing. A bubble formed. Well, I can push it out. This could be due to the very, very strong lifting. It's possible that I don't know. The strong lifting, yeah, the lifting forces from just these two parts way exceed what I typically get. Anyway, so let me drain this part, and then I can show you how interestingly fluid this is. I mean, you can even see it, right? This pours like almost like water. It's very, very runny. And so this probably wouldn't hold pigment for a particularly long amount of time compared to the FunToDo resin, where pigment takes days to settle. The color seems to have avoided the loss of detail. Yeah, so the detail here is quite good, particularly compared to the Venus Clear, right? Because the Venus Clear is similarly clear, but not orange. It's just barely like a off-white ivory color. But that difference seems to have made all the difference, because when I ran Venus Clear doing the meetup at Tech Shop, ran it with like a 4-second exposure time compared to here where I'm at like 8. And details are way better, and I think that I can cut the exposure time some. Like my layers 2 through 15, bottom support layers probably don't need 45 seconds, probably only need maybe 30 at a 10th, maybe less, maybe like 20 to 30. Upper layers, 10 seconds, also probably more than I need. Probably could do with less. Maybe go 8 instead of 10, 8. Maybe 9, 7, or 8, 6.5. Let's shift the camera a bit, and I'll show you as I pour back. Where's the bottle? Hold on a sec. Sorry, blowing a fan at this bottle here. So let me switch camera angles a bit. This has a peculiar odor. It's smells vaguely like, I don't know, herbal medicine or something. Very peculiar odor. I'll have to say the odor is much more unpleasant than the FunToDo resin. Check the MSDS. I wonder, it just doesn't have that acrylic smell, because the MakerJuice had kind of a similar odor to the FunToDo IB. This just smells totally different. So anyway, let me label my bottle, 3DM ABS. This stuff really, yeah, when they say it attacks, right, you can see that it's like, it gets into the nitrile glove here. Right, this orange streak. So usually if FunToDo gets on the glove, I can just wipe it off. But this has actually gone into the glove. I would have to make sure that it doesn't go through the glove. Well, on this, yeah. I wouldn't say that it's an extremely strong smell. I mean, you can't smell it outside of this room. But it does not smell good. I'm gonna have to be kind of much more careful of spills of this stuff. This stuff just seems more unpleasant, although it prints great. And I suppose that would be the case. Like maybe if you got the polyester resins from Bucktown Polymers. Polyester resin is nasty stuff. This doesn't smell nearly as bad as polyester resin. But if you take a look at this, this pours, this is just so, it's just so thin. It doesn't pool at all. And then you're so of course supposed to rinse this out pretty much right away. Let me squeegee this down. This is the this vat. This vat is the 3DM V1 vat. This is not the V2 vat. My V2 vat has it's turned red from all the red pigment that's kind of infiltrated the soft silicone part. All right. So before I go rinse this off, I suppose I can spend just a few minutes taking a look at this. So we've got our parts here. It is surprising. The odor is not strong, but it's unpleasant. It's surprising how much more unpleasant 3DM is. Because the MakerJuice and the FunToDo certainly were not odorless, but this stuff just did not smell good. Alright, so take a look at this part. The detail on the top is pretty good. The threads on this test part came out. So this orange makes a huge difference in overcure compared to the Venus Clear. Because the Venus Clear at, let's see, I did half the exposure, but it was also half the layer time. So that's roughly like maybe 30% net reduction in dosage. The part is quite strong. So there's this. Where is the steel? Oh, here it is. Steel scraper. Well, 70 seconds got some pretty extreme build plate adhesion. This is wow. Okay, so could not get that off the build plate with the supports intact. So it did come off the build plate, but somehow, maybe because that attachment layer is really brittle, you can see that when I pulled it off, it ripped off all the attachments. And I see, because this stuff, I can feel it now that I'm kind of touching the support. It's hard, but it's not extremely rigid. It's certainly more rigid than ABS. So we'll say that I suppose the FunToDo resin, when they say that it's kind of ABS-like, the industrial blend, it doesn't quite have ABS hardness, but it has some of that flexibility. And this maybe way on the other end, really hard. Well, quite hard, but yeah, nothing to speak of in terms of flexibility. Yeah, this stuff's just. I've switched to trying to using more shop towels and less rubbing alcohol. The idea of dumping, in the end, quarts and quarts of alcohol down the drain just doesn't seem right. Yeah, so it comes off the build plate, but that attachment layer has no strength in that direction. So yeah, and so the support just come right off. But all right, so let me take these two parts here, wipe them down a bit, because when we saw the pictures of the 3DM, right, it has this kind of matte finish. Of course, right out of the printer, they're real shiny. And this was similar to the print out of the Venus Crater too. After you finish them a bit. Wow, I got shattered bits of the attachment layer, kind of shattered all over from the brittleness. Anyway, what I was saying. Kind of like the Venus Crater, it also doesn't. It has a glossy to begin with, then it loses its gloss. It'll lose its gloss, and then you can polish it down. All right. So that is. Use the microfiber cloth too. But wow, the down-facing surface, the side that has the vat texture, it's just real. It's just real smooth, real clear. You can see all the way through down to the kind of the slightly over-cured, extra dosed backside. But even then, the over-cure is just not that bad. Right, because when I first start, okay, so I'm doing 10-second exposures, then down to 8. So even though I was dosing at 10 seconds, I was dosing high enough that I was having trouble getting the layer to fully release. But even there, you don't see the blobbing, right? Because when I did the Venus Creator, I had tremendous blobs. I mean, the overcure from the light shining through for the remaining layers would basically completely encapsulate the support, which my support just kind of disintegrated. Completely encapsulated the support, made a huge blob all the way down to the attachment layer. But here, we actually have quite a good surface here. A little sticky, right, because it's gotten cured, and then but not enough dosage to fully cure. So there's this uncured layer, resin layer here, as opposed to this top side. All right, you see some layer stretching here, but it's really not bad. It retained its shape quite well. So interesting stuff. So I'm thinking maybe my consistent layers will be around maybe 7 seconds. Maybe I'll go 9-2 for the upper attachment. 9-2, 9-7. 9 seconds for the upper attachment, 7 seconds for the layers as a test. Probably run these off again. I might run them off quickly before cleaning the vat. And yeah, but does not smell good. Oh well, can't win them all.